gradient phi. It's gradient. Gradient means what? Derivative changing respect to what? Position, right? So gradient is a vector. Let's say the v u is a vector. So gradient u is a vector, and this will be like e1 partial something partial x1 e1 plus partial x2 e2 partial x3 e3 on phi. It's gradient. Okay, so this is a scalar, and its gradient become a vector. Okay, the gradient of x direction variation maybe well different from the y direction, x2 direction, 3 direction. Okay, so in notation we use this symbol. Okay, this symbol. Okay, this thing we say is equal to ei partial xi. It's equal to partial e1 partial e1 partial x1 plus e2 partial x2 e3 partial x3. Okay, so this will be means the partial phi partial x1 e1 plus partial phi partial x2 e2 plus partial phi partial x3 e3. We call this gradient. Yeah, gradient. And this is called the Hamilton operator. Hamilton operator. Okay. Or we call the gradient operator. Okay, gradient operator. Okay, gradient operator. Yeah. Or yeah. So from theory here, my ui equal to the phi comma I. Okay, we write this way. Okay, so it's equal to gradient phi. Okay. Because this is a free vector, right? But comma is differentiation with respect to xi, but direction in the I direction. It's a vector. Okay. Yeah. The second thing I related to this Hamilton operator is the divergence. Okay. So this is a gradient of a scalar function. So we also have a gradient of a vector. That will be what? Gradient of a vector. For example, v. What does that mean? This would mean partial xi ei put together with a vj ej. So this will be partial vj partial xi ei circle cross ej. Put it together. Okay? See what I mean? So that will be also a Vj, comma I. Ei, Ej. So this is a tensor of order 2. The gradient of a scalar is Ui, Ei. So this is a tensor of order 1. So gradient of a vector become a second order tensor. Okay? Different from gradient of a scalar. Gradient of a scalar is a vector. I want to emphasize this. Okay? So I introduce you this operator, right? And you can think as a vector put together. Put together. Okay? Put together, I would like to write this form. Put together. Yeah, this is Ei. Put together with Ej, but instead of confusing with dot or with not dot, I emphasize this is a put together. No dot between. It's not in the product. Okay? Yeah. All right, the second thing is about the great divergence. Okay. We say divergence U means this dot U. Okay. Divergence means dot U. See what we have? That will be partial xi ei dot uj ej. So that will be uj comma I delta ij is equal to ui I or ujj. Okay. So when you see this repeated things with this common there, this is called divergence. Divergence. The vector divergence. Okay. Yeah. So about these things, you should go back to check your undergraduate mathematics 2, see? Divergence theory. Remember? Forgot. Okay. Anyway. But today I will show you some very simple formula. It's when you in the future, because when you derive an equation, sometimes you meet something like when you got a tensor form, but finally we'll change to a vector form. That'll be more general, because this form is good for any coordinate system. Okay, I just use one Cartesian coordinate system, but maybe you can change to what? Spherical coordinate system, or curvilinear coordinate system, or X-prime system, whatever, right? Well, but it's good for us. So this, why we learn this tensor notation? Because from tensor notation you can prove a lot of equality equations. I will show you later. Okay, yeah. Very powerful. Yeah. Yeah. Now today you learn it, and if you keep on practicing, you get more familiar with. The simplest tensor algebra. Okay, some people show it to the Christopher symbol, upper index, lower index. If you don't use, you forgot it. Okay, but this is Cartesian, very easy to memorize. Okay, yeah. All right. So This is a divergence, means inner product divergence. Okay, and the third one is a curl of vector field. Okay, curl U means this cross with U. Curl. Okay, curl. So that means the we call the E1, E2, E3, partial x1, partial x2, partial x3, U1, U2, U3. Remember? Right? Or if you like, we can do this partial xi, EI cross UJ, EJ.